Okay, according to this, we are live. The internet hears everything I say. You know what they say? In space, no one can hear you scream. Unfortunately, on the internet, everyone hears you scream. It goes viral, and before you know it, you're a YouTube sensation, enjoying your 15 minutes of fame and shame. All the joys. Okay, so in anticipation of today's fight with the technology, because it wouldn't be a normal day in my class if it didn't fight, I've got a driver, designated driver. Could I get you to click here real quick for me? That's right, folks, designated driver, that's useful. All right. So, my understanding is we had some technical difficulties over the last few lessons. Yesterday was obnoxious, and apparently last week obnoxious. People are like, Matt, normally you bore me to tears, and the sound of silence was beautiful and all. But I really did want to see your ugly mug explaining the mathematics behind it. That's why I clicked the stupid channel thingy. So, yeah. I'm sorry. If for any reason that thing turns off, I wish it would beep or yell at me or something. But it doesn't. I put in new batteries. If they don't work, I'm sorry. We'll check it out. So let's do a quick review all the way back to 5.5. Now, of course, if you're going, what? Scratching your head, this isn't in the cow book. This is in the other book. And so on this, 5.5 was distributive property. And on this, we had problems like this. 2x times 3x plus 1. And on this, we were just to make sure that we remembered when we multiply, multiplication distributes across addition or subtraction. Which really I could just say across addition because we know that subtraction is addition of the opposite. On this, 2x times 3x, 2 times 3 is 6. X times x is x squared. Oh my, that's scary, the thought of my x times my x. Oh. 2x times 1, so that would be positive 2x. A lot of times people get to this point and they're like, okay, and what do I do now? What does it mean? Why is it there? Who knows? That's the end. That's as far as we're going. We're just practicing a skill. It doesn't mean much of anything. It just means 6 times something that's times itself plus 2 times that something. That's it. Bookmark, placeholder, who cares? All right. So then we go into the next section, which we were talking about it. This is dividing by monomials. So you get numbers like this. Well, beautiful expressions. 5x squared. Oh, go away. I've had this thing open earlier today. It didn't yell at me about it then. 5x squared minus 10x. Now all I'm doing here is using the distributive property in reverse. I'm going to divide both by 5x. What is 5 divided by 5? 1. X divided by x, or excuse me, x squared divided by x, x. So I'm just going to get here an x. Negative 10 divided by 5, negative 2. X divided by x, 1. And of course, if you remember this, oh wait, you couldn't hear me as I was talking about leaving the kids on top of the car. Now that's a funny story. With that, before anyone calls CPS, we'll talk in a second about it. With that, I can't just forget my children. I can't randomly forget them. I've got to bring it along for the ride. Now oftentimes I'll see people hit this step and they'll go, okay, and now I put it back together, then I break it apart. Back together, break it apart. Back together, break it apart. Right? No, we're done. Do what it says and stop. Because you can go back together, apart, so on and so forth all day, and all you're going to do is drive yourself insane. Oh yeah, unless you make an error, at which point, well, then you're just being a silly human being. All right, ready? Designated driver, and 3, 2, 1. I clicked. Thank you. Now we're going to go to the next section. And on the next section, this is where everyone went in and they said, okay, Matt, there is no sound. And I said, oh, How about that? Shall we make sure? Is there sound? Yes, there's sound. Says so. Says it does. It does. Why are you laughing at me? It has sound. It says so. All right, fine. I just work here. So we were doing division of polynomials, and I showed a regular division problem. Let's take my friend 125 and divide it by 5. I mean, isn't that just a beautiful number? No? Fine. No beautiful number. Fine. All right, 64. And we'll divide you by 4. What do you guys think? No? I got it. 343, and we'll divide it by 7. Is everyone happy now? Thumb poll. Yes, yes, no. No. Why? You don't think it's going to go in evenly? Interesting. Should we find out? Is it not? Well, let's see if we get a remainder or not. We're going with it just because you said that. Now I have to find out for sure. As if I don't know. All right, 7 can go into 34 4 times. So now I take and I say 4 times 7, 28. Draw the line, change the sign. That's going to give me a 6. Bring down the 3. 7 will go into 63 how many times? 9. 9 times 7 is 63. Draw the line, change the sign. Now, when I show this to people, they're always like, why is he draw the line, change the sign? Draw the line, change the sign. That's right, exactly. You gotta know exactly what you're doing, otherwise you will fail at life. Well, guess what? Today is later. For anyone who wasn't here in person hearing it the last time around, for anyone who was, this is a repeat. So let's have a look at this. We're going to divide by a binomial. Here we got x squared minus 5x plus 6. And we're going to divide that bad boy by x minus 3. You know what? I don't like that location. That's not happy. Let's try that again. X squared minus 5x plus 6. And I'm going to divide it by x minus 3. Right? Sure. Happy. Doesn't that look beautiful? All right, now let's treat this like I did the other one. When I did the other problem, I said to myself, I said, self, dude, shiny colors, the light's in your eyes. Okay, no. What I said to myself when I was looking at the number was, 3, 4, 3. 7 won't go into 3. That's the first thing I was looking at. Whatever is right here, that's what I'm paying attention to. I'm like, oh, look right here. This is where I'm looking. That's what my brain is telling me to do. So on this, how many times will x go into x squared? Well, 1 times x is x. 28. 32. If we're going to throw out some random numbers. Oh, were you being serious? I'm upsetting you. I'm sorry. Did you mean like x squared or x to the first, maybe? Yeah, she's getting mad. All right, so let's put down x, because x times x is x squared, right? Isn't this beautiful? So I write x times x, x squared. Am I done? Amen. Preach it. Because I'm looking at distributive property. Hello. X times negative 3 is negative 3x. Now watch this. Draw the line. Change the sign. Oh. Oh, what just happened? Do you see what just happened?
So why did you write a negative?
Oh, yeah. That's where I get to come across like I know what I'm talking about. All these times I've said draw the line, change the sign. This is why. Because we know of division as multiplication by the reciprocal or repeated subtraction. Equally grouping. Whatever we want to look at it as. Here I'm subtracting. And when I subtract a negative, it becomes a positive experience. Right? 4 minus negative 2 is 4 minus negative 2. I would agree with that, but 4 minus negative 2. You're just being difficult now. For those at home who may not realize it, she's playing around hoping I'll feed her chocolate later for this. That's exactly what it is, see? Thursday. We're bringing in chocolate cookies. All right, so 4 plus 2 is 6. When we do that double negative, you remember? It's like the party. You put two negative people together. It's a positive experience because they're going to be so crazy the rest of us are entertained. No, it's not. So it becomes 4 plus 2. It was 4 minus negative 2. So minus negative. Here we have minus 3x, right? Well, we're subtracting. That's what we're doing, repeated subtraction. So when we're changing the sign, we're indicating that subtraction. And that becomes a minus negative 3x, which becomes a positive 3x. Is that not beautiful? I know, it makes my day better. Okay, so how many times will x go into negative 2x? Okay, what do I multiply x by to get this? Because negative 2 times x is? And negative 2 times 3 is? And that's positive. Draw the line, change the sign. When I do, I get a remainder of 0. If for any reason I'm doing this and I get a remainder, I just write it over the divisor. Isn't that happy? I love it too. All right. So now let's continue. Yesterday, we went into chapter, we were calling it 6.0.6.1. And we did greatest common factor. So here we have 15x plus 25. And on this, I'm just looking to break this into pieces. This is the brick wall all over again. We do not like to run into brick walls. We want to break it down to smaller pieces, right? What is common to both of those? 5. So I divide them by 5. And I can do this showing the division because I've learned it. Or if I can see it, I can also just pull it out and go 5, 3x plus 5. If I want to check my work, I just put them back together. It's factoring. That's it. That's as far as I go. I'm happy. The world's a beautiful place again. Isn't that awesome? Greatest common factors can be anything that's common to multiple terms. So like this one. Seven and 4 have nothing in common. Can I factor anything out of that? No. But look, there's an x in each one. In fact, there's x times x. I can factor those out. So when I say factor, pull out greatest common factor, I always want to pull out the biggest chunk I can from both terms. This is the same thing we were doing with arithmetic in Chapter 5. And by that I mean Chapter 5 in the cow book. This is the same exact thing. We're just pulling the greatest amount from both piles that we can, their intersection, if we want to go back to set theory. On that, I can pull it from multiple terms. There can be 5 terms up there. And if they all have the same thing, I can pull it out and put it in front. When I do, I need to bring it along for the ride. There's a sign at the Walmart that says, be sure that you checked your car and didn't leave your children behind. Just like to take a minute, remind you, don't leave your kids behind. Don't leave the children behind. This factor is one of your children. If you leave it on top of the car and drive away, people are going to get upset at you. Right? This has applications later on in life too. Alright, so now we also went over, because I skipped ahead, we went over the 6.4 and 6.5. So let's talk about those real quick. And that's, of course, 6.0.6.4, 6.0.6.5 for anyone at home going, where is he going? It's in the remedial, the stuff I'm catching up for the cow book. So on this, we are to factor the following kind of things. And here we have x squared minus 9. And so I talked about this, and I taught about the whole difference of squares. The first thing I want to say is a sum of squares. That's where the sign between them, they're both a square. The sign between is a positive. A sum of squares is prime in the real numbers. We're only playing right now in the real numbers. No angry letters, please. A difference of squares factors as conjugates. And that's very important. I want you to remember that word, conjugates. That can come up later on in life when we're talking about complex conjugates, things like that. It can help me find zeros of a function, etc. Very useful. If you're at home right now going, Matt's talking Greek, that's okay. Later on in life, if you watch this video, you may be like, yeah, I had to take that in college, and he was right. I'm glad I remember conjugates. It made sense. So conjugates, if you have a squared minus b squared, they're both clearly squares. You just take the square root of a, and so that's, of a squared is a. The square root of b, bring it down, minus a plus b. The order does not matter on these. Remember, we are factoring. When we factor, order does not matter, and let me clarify that. The factors here. I can't willy-nilly change b and a. If I did, I'd have to do some weird stuff with a -1 to make it a true statement. I can, however, when I get here, write a plus b times a minus b. And I'm not lying. I'm not changing anything. I can't willy-nilly change the side of b and a with a minus because we know subtraction is not commutative. And if you're at home going, huh? Rewind, go back to like that section. It's in chapter 4 or 5 that we did that. And we talked about commutative properties, if it can switch lanes. Then we went over a more fun thing. We went over sum and difference of cubes. And on that we said, okay, if you have sum a cubed plus b cubed, that's just equal to a plus b times a squared minus ab plus b squared. And I pointed out that I would like you to be writing these down every single time you use them. You'll memorize them that way. Now we look at a difference of cubes. A cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. And I pointed out a few common things here, one of which I'd just like to point out. If you look at the signs here, and I'm going to do this, we'll be fine if we do it here. This sign here, and this sign here. Look at the connection here. And then if we look at this sign here, and this sign here. I don't have to memorize them as separate formulas. I can memorize the fact that they have that relationship. And just remember, the difference of squares, the minus comes first. Difference of cubes, minus comes first. Sum of cubes, plus comes first. That's all I have to do on these, and I'm happy. Now on that, we're going to run into some fun things. So let's have a look here. Even though it's not in what I assigned on the homework, we're going to have a look at number 34. And this is from 6.0.6, if it'll write, 6.5. There we go. Now, when I look at this, I've got 125a cubed minus 27b cubed. Now on that, my first thing is I'm going to look and I'm going to go, is there a greatest common factor? Anytime I'm factoring, the first thing I always look for, greatest common factor. Repeat after me. Thank you. One time, and people who were here yesterday are bored of this story, I was hung up on a calculus problem. It had been over an hour and a half that I was working on it. And I had a whiteboard covered with this large, impressive looking, to people who don't know better, to people who know advanced math, they were probably shaking their heads at me. That's okay. Problem. And the professor, who is my mentor, he teaches every day how to factor. I mean, that's mainly his bread and butter is right here. And in this lab, all of us tutors were standing around taking turns looking at this thing, trying to solve it, trying to break it, trying to figure it out. He's walking by. He had just gone to get a Dr. Pepper, his favorite drink. He walks by, looks at the board, sees us doing the, and he goes, greatest common factor. And we're like, oh. Suddenly the world's a better place. So if you find you're hung up and you're factoring or you're trying to get things alone, greatest common factor is the great place to start. Save you an hour and a half of your life. All right, so on this, I'm looking greatest common factor. 125 and 27 do not have a common factor. I'm going to go on ahead and continue. On this 125, I can write that as 5 cubed a cubed. 27 minus 3 cubed b cubed. Now I just have to remember the formula. Well, the formula is, let's see here, that's subtraction, so it's a difference of cubes, therefore it's a minus b, a squared plus ab plus b squared. Now I just plug these in. This is my a term. This is my b term right here. Just looking at the 3 in b and the 5 in a. So I'm going to take a look at that. 5a is my a term. So 5a minus 3b. Then a squared, that's just going to give me 5 times 5 is 25. A times a is a squared. So 25 a squared. Now a times b, that's going to give me 5 times 3 is 15. A times b is ab. And because that sign went to positive, it's plus 15 ab. Now I'm going to do the last term, and that's b squared. 3 times 3 is 9. B times b is b squared. There we go. Happy things going on. Now, when we're talking about real numbers, this is now prime in the reals. If you're breaking something and you use the sum of cubes formula or difference of cubes formula to break it, and you get here, don't try to break that thing. I mean, it can be broken. We use quadratic. We use other methods. But you don't have to worry about it. If you're factoring, it's down to a prime in the reals. Are there any questions related to this? What was that? Along the way? Sounds good. All right, this is the day I have been waiting for. We are going to teach today more fun things. I'm going to teach you how to factor a trinomial. When you run into a trinomial, these are the tools that I want you to consider using in the order I want you to consider using them. Now, if the instructions say to use one specific tool, use it. Save yourself some time. But be aware, greatest common factor is always needed. So, I'm going to factor a trinomial. My first step, always, always, always. First step is to look for a GCF. My second step is to look for a PST. My third step is to look for an LC equals to 1. Fourth step is to look for an LC greater than 1. Fifth step is quadratic. These are in order of ease of use depending on the individual. Quadratic is a sledgehammer. It does amazing things. You can use it to clean up a lot of ugliness. It also comes with a cost. It takes some time. Sometimes it's much faster to factor the other ways. So shall we look at one that'll kind of make us go, huh? We shall. The first step. Okay, clearly we are going to pause the lesson and the video.